This is problem 6.6 in the AP review book. So a 2 kilogram block is dropped from a height of 0.45 meters onto an uncompressed spring. The spring has a constant of 200 Newton meters. For part A, we have to determine the spring of the block the instant it hits the end of the spring. To do this, we just do mgh equals 1/2 mv squared, which is conservation of energy. You then cancel out the m's, and you say v is equal to 2gh square rooted. You then plug in gravity, which is 9.8, the distance, which is 0.45, and you solve to get a velocity of 2.97 meters a second. For part B, it is asking for the period of the simple harmonic motion of the spring that ensues. The equation for period is 2 pi over omega, which is then changed into 2 pi square root m over k for a spring. From there, you plug in the spring constant and the mass, you solve to get a period of 0.63. For part C, you have to determine the distance that the spring is compressed at the instant the speed of the block is at its maximum. To do this, we set ky is equal to mg, and then you solve for y by dividing by k, plugging in the numbers again, and then you get a distance of just under 1/10 of a meter at 0.098. For part D, it wants to know the maximum compression of the spring. Again, you use conservation of energy, set 1/2 ky squared equal to mg y plus 0.45, which is potential energy, and you have to include the 0.45 initial height for the compression of the spring, which is y in both cases. Then plug it into your calculator, and you get an answer of 0.41 meters. For part E, it just wants to know the amplitude of the spring, and that is simply your answer from part C subtracted from your answer from part D, which is then 0.312 meters. And that is the whole problem.